So here's a good example of what we're going to be working on, or at least what it will make when we're done working on it. And then here's the code. So I figured I'd put all that at the beginning of the video in case that's what you're here for. But if you'd like, you can stick around and hear me explain everything. Just remember to hit the like and subscribe button. Thanks for watching. So I start off by making two scenes. The first is going to be the world, just for the game or the app, I guess. And then the other scene is the tile scene. Now, I actually already have a tile image for the sprite that I add to the tile scene. You can make your own, or you can use the icon in the game. It doesn't really matter. With both of those saved, I just add a script to the world scene, just the parent node in that scene. And then I just start working through the code for the level generator. So the general idea is that it's going to generate a grid of tiles. We're going to start by loading the tile scene, or preloading, before the ready function is even called. I outline 4 directions in a direction array. So there's vector2.right, left, up, and down. And those are just the same as doing a vector2 that has 0, 1, 0, -1, 1, 0, -1, 0. I outline a few variables: grid size, grid spread, the grid itself, which is going to be the empty array that we add the tiles to, and then also grid steps, which is the number of times the algorithm will run for the random walk function. The ready function is very simple. I just call randomize to make sure we're getting a different result every time, and then I call a create level function that I haven't defined yet. In the create level function, I just lay down a couple variables. There's going to be current pixels and current position. The way that I try to distinguish that is that the current pix is going to represent the pixels on the screen, like the actual coordinate position by pixel, and then the current position is just going to be in relation to the first grid. So if you go 1 grid to the left, it'll be -1 for the X position. So current direction starts off as right, but that's kind of arbitrary. We're going to replace that. And then last direction, we're just going to take the previous direction, multiply it by -1 to kind of inverse it. So now I do a loop equal to the number of grid steps there are for the random walk function. And then I copy the direction array that we set originally with all the 4 vectors in it. I'm going to duplicate that into this temp dir variable and then shuffle it. So we randomize the order of it, and then the next thing is to pop front, which essentially just means we take whatever's in the front of it and we pop it off, and now we have that. So that's why we shuffle and then pop. It's the same thing as getting a random direction. Then I go through a series of checks to make sure that this is the type of direction that I want. I don't want to go outside of the grid, and I don't want to go in the opposite direction that I just came from, if that makes sense. Like if I just went right, I don't want to go left, because then we just backstep, and there can be a lot of dead ends if I do that. And you could have that, that's fine, but for this I didn't. So these first two, the absolute values of the X and Y positions plus the new direction, are just making sure that we're within the grid size. The reason I do absolute value is because we could be on the left side of the grid, or the right, or the top, or the bottom. It doesn't matter. We don't want to go outside. And then I check to make sure that our direction is equal to our previous direction. Well, I'm checking to make sure that it's not equal to our previous direction inversed. And then if any of that is true, then we'll just shuffle the list and we'll pop the front again. The reason we shuffle again and we don't duplicate again is that way we kind of lose. We've already found one that we don't want, so we leave that off and we just shuffle it again. As long as everything works, we take our current position and we add the new direction, and then we take our current pixel position and we add the new direction times the grid spread, which is basically just how we're separating the tiles. Set the last direction to the current direction. Then we actually create the tile. So we preloaded the tile. Now we just create an instance of it. We set the tile's position to current pixel position, and then we add the tile as a child to this node. If you want, you can append that child to the grid array. That way we just have a reference to all of them that we created. So this is where I fixed a little mistake where I put in the scenes, just because that's what I'm used to doing. And then I also forgot to do dot shuffle. For some reason I did equal shuffle. but that should work. So just to make sure that you can actually see the tiles a little bit better, I should have created a node within the world scene that was the level generator just so we could position it. So I'm actually going to add a color rectangle just to give a background so that you can better see the tiles that I created. I'm going to set the size of that rectangle to the size of the game window. And then in the world scene, I'm going to add a node 2D, and that's just going to serve as basically just a position. I could have used a position node, I think, but that'll just be where I use the script that I created mistakenly for world. But we'll do the same thing, and then I'll move that level node to the center of the screen. And then when it generates the tiles, everything will be centered on that node. And that's it. So now we have a random walk, roguelike dungeon tile generator. Very simple, very easy to use, very customizable. You can change the behavior of the algorithm in a lot of different ways to create a lot of different effects. But I think for such a short amount of time and really not that much code, I think it looks pretty good. I hope this made sense. I can change these variables, grid size, grid spread, and you can see kind of how they affect the outcome. But I would encourage you to take this code and then just play around with some of the behavior. You could make it, just some ideas, you could make it move. If it can move more than one time, you could make it kind of step further than just one at a time so that there's more pathways. There can be longer pathways. You could set it up to generate kind of these pre-made room shapes at different points so that you could have, you know, hallways leading between rooms. You could do a lot with this, but this is a very good start. Hopefully you enjoyed the video. If you like stuff like this, I'm gonna try to make a few more videos on kind of the elements of a roguelike and things like that. But this was a lot of fun. Thank you for watching. I hope I see you in the next one.